So the philosophy is that with a few very sharp tools, you can get really far. And we want things to be simple, like to stay simple data structures, simple types, not too much magic, essentially, because we believe that makes things more maintainable, more approachable.
Hello, welcome to DevTools-fm. This is a podcast about developer tools and the people who make them. I'm Andrew, and this is my co-host, Justin.
Hey everyone, we're really excited to have Gabriel Nordeborn on with us. Gabriel, you work on the Rescript team, and Rescript is a language I've had my eye on for a long time. It looks really awesome. So it's like a purely functional, like strongly typed language that has more of a sound typed system than TypeScript has, but it like compiles to JavaScript. So I'm really excited to dig in and talk more about that. But before we do, we'd like to hear a little bit more about you. So would you like to tell our listeners a little bit more about yourself?
Sure, of course. Hey everyone, waving for those on the audio podcast. My name is Gabriel. I'm out of Stockholm, Sweden. I got 2 kids living here. I've been involved with Rescript language itself for maybe 3 years or so now. And I've been working I've been a software developer for over a decade. But originally, I'm actually a behavioral scientist. So I studied a bunch of psychology in university. So that's where I got into this. And then I fell into the programming stuff as well. I've always been doing a bunch of programming when I was little, like back when CSS was actual attributes on the DOM nodes only, no like actual style sheets and those things. When guest books in PHP and MySQL was the big thing, like that's when I had my start in programming, so to speak. And then I tried to avoid going down the engineering route just because I didn't want to get stuck by the computer for the rest of my life. And it worked out really well throughout university. I did the psychology stuff. And then when we're almost done with university and I had to do like my master's thesis, I slipped back in. I did a web-based experiment. And then I ended up getting a job as a developer. And then that's the kind of where that comes from. I've always been very interested in and involved in open source. That's very important to me and something I value highly. Even before I did development, I was very interested in open source and using lots of open source software, helping out like debugging and stack traces and whatnot.
So was that first project like the intersection of your degree in programming, or was it just like some project?
No, it was a really weird experiment. I wanted to. There's like color psychology, a small branch of psychology with not lots of research in it, but there's a bunch of like theory around colors and how colors can affect us and how that's like culturally bound. So I did an experiment where I set up a WordPress site that kind of mimics a medical information site. And then I had my cousin, who's a researcher for medicine. I had him make up a disease and then put that disease somewhere in the website. And then people had to find information about the disease, ingested kind of and answer questions. And then the manipulation was 3 different color schemes. So did that affect the speed of and the level of comprehension and those types of things? Didn't really affect that. Like there was a small like 3-way interaction between like being a male and the red color theme, which had an impact that was like people were slightly slower on the red theme, and then you could theorize a bunch of that's because back in the Stone Age when your enemy got angry on you, like they had a red face and that makes you scared, and comprehension goes, yeah, you get the point.
Yeah, that's interesting. I feel like blue might have some association there. There has to be a reason that every company uses blue.
So blue is really, that's soothing and calming and those, but apparently it's different in Eastern cultures compared to Western cultures. Red is more soothing there, apparently. So it's, interesting thing. But when I did that, and after I did that, and I came out to trying to get a job, turned out that this was back in 2014 or so. There was like 2 jobs in Sweden for behavioral scientists and 2,000 jobs for developers. So like that was the logical choice. So I'm here at the computer for the rest of my life anyway. I guess I gave it a shot at least.
So how did that lead you, like where in your journey what led you to discovering Rescript?
I got started with PHP. That was my base starting out. And then as all the things I've come to then love, I hate them at the first sight. We were doing lots of client work. I worked at a web agency and sometimes needed more interactive stuff than you could deliver with just server-side rendering. So like natural thing, JavaScript, right? And back then, this was just when React had came out, essentially. It was still the new thing on the block. Angular 1 was the big thing, Backbone, those old frameworks. A colleague of mine showed me React. I instantly hated it. Looked terrible. Why would you do... I think I specifically said, like, why would you ever do anything with JavaScript if you just have PHP and the server, right? You have your query parameters, you can just re-render. But we had a couple of requirements which made that we had to use that, and so got into it. I warmed up to it. And then eventually, since I like to think about these things and analyze, eventually I saw Flow back when that was the hot thing. Before TypeScript, when TypeScript was a thing but wasn't really that hot. This time has actually existed. Now, looking at the graphs now, you wouldn't believe that, but this was back, like Flow was a hot, interesting Facebook project. Facebook had a massive momentum going with React and all of the open source stuff they did. So I looked into Flow, saw that, wow, there's a way to discover bugs and issues before we ship it to the clients. Excellent. I didn't have a background in any of the type languages in that sense. I done a little bit of like C and stuff, but yeah, doesn't really count. So I thought Flow was really interesting. And then I eventually also, of course, got into TypeScript. But we used Flow a lot, used TypeScript a lot. But it was always like, I was always looking for more, so to speak, in terms of type safety and those. And then back then, this was maybe 2018, the first time I saw this, ReasonML was a thing, and BuckleScript. So I slipped into that, landed on that, and quickly realized that this is what I would like Flow or TypeScript to become for me to be happy with it. Maybe not. It wasn't perfect back then, neither is it now, but still, if you compare it to the goals of Flow or TypeScript and the goals of ReasonML BuckleScript back then, that was much more what I was interested in. As soundness in the type system, the inference, clear data structures that's easy to work with, the mutability, and not like I'm not at all a hardcore functional programming enthusiast in that sense. I'm very much a pragmatist. Like I want to do stuff that works, that I feel like works, and that I can prove over the long run works. And a type system that is sound, that you can trust with nominal types instead of structural types, and those types of things in places where it matters, that just resonated with me very much. So I started getting into that. So that's how I got into that from the beginning, essentially.
Cool. We're big fans of TypeScript on the podcast. I'm literally wearing a TypeScript sweatshirt right now. We sell it at shop.devtools.fm. But one of the features of TypeScript that I've come to love that a lot of people hate is like that it's a powerful type system, but you can throw it out. So I guess in a sense that I love the unsoundness in some places where I can be the arbiter of my own destiny, even if the types don't quite work out. What does a sound type system mean in practice?
So in practice, a sound type system means that if it compiles, it works. If this is true for the internal things. So if you compile a program, the compiler guarantees that the code you've written works in the way you've written it, the way it's outlined, so to speak. Then, of course, you have the edges, so to speak, like values that come in from the outside. You have to type them the right way or handle them the right way, because those are, things can slip in. But if you have a program that's written only in Rescript, for instance, and it compiles, it works according to what you've written, so to speak. That's the guarantee of a sound type system. And again, like it's interesting that you with the unsoundness, and I think we probably think more alike than you would imagine, even though I go for the like sound type system stuff. I'm not really. I find type systems fascinating and fun, but I'm only interested in what it gives me in practice. And what a sound type system gives me in practice is that I can trust that the things I write, the things I ship, will work according to the way I've written them. I can do refactors easily, but the biggest thing for me is if I do a quick change in a massive application, it compiles, I trust that this is going to work. I trust that this hasn't accidentally broken things outside of like behavioral, of course, stuff, but this hasn't broken anything anywhere. And I can also trust that the compiler is going to guide me to handle all of the cases I need to handle. For instance, in Rescript, everything is exhaustively checked for you by default, which means that the compiler will make sure that you handle all of the cases that you are supposed to handle for this to work in all of the branches you have, essentially. If you have an enum, for instance, and you want to do something with that enum, Rescript will make sure that you handle all of the possible cases of that enum, unless you explicitly tell it that you're not going to, essentially. And there's a massive productivity gain for me from that. So looping back, I think what you describe, you can just opt out whenever you want to get the productivity gains. I feel the exact same way, just that I do it through I get my productivity gains in another kind of area, so to speak. But then there's a whole category of programming languages and programmers that care deeply about that it's sound for the sake of being sound. And I'm not one of those. In that sense, that's not really what interests me. That's cool if that's the case, but I'm interested in the productivity it gives me and the guarantees it gives me.
Let's take a step back real quick and talk about Rescript more generally. So Rescript is a programming language that compiles to JavaScript, and it has a sound type system. What else would you say about it?
So Rescript it's a programming language that's focused, I would say it's focused on the web. It's focused on simplicity and speed. Like speed is a core feature. It's something we care deeply about, that we have a fast compiler, that we have a fast feedback loop in the editor, that we have a fast feedback loop wherever there's an interaction with the language itself. We care deeply about simplicity. The way I usually describe it is, if you want to contrast it to TypeScript wants to type the JavaScript you've already written, or the JavaScript that you write. You're writing JavaScript and it wants to type essentially everything in JavaScript, right? And it does it really well. So TypeScript is fantastic at what it does. It's an amazing type system, an amazing feat of engineering overall. It tries to type all of JavaScript, and all of JavaScript has grown over the years to be a pretty massive shed of tools. Can't really clean it up too much because you'd break a lot of the web, which is, you don't want to, right? You can evolve the language. TC39 is evolving the language, but evolution is slow, and still there's a massive amount of features. There's a massive amount of ways of doing things. So imagine there's a shed of many tools. Some of those tools are really sharp, are really good, really well thought through. A lot of those tools are not that sharp, doesn't fit that well together, or there's 4 or 5 different tools that do the same thing from different generations in a tool, like in a product line, and so on. Rescript's philosophy and idea is that if you open the Rescript tool shed, you'll try and where's all the stuff? You look around and try and find all of the tools. But the point is we want to have few tools, but that are really sharp and work very well together, essentially. So the philosophy is that with a few very sharp tools, you can get really far. And we want things to be simple, to stay simple data structures, simple types, not too much magic, essentially, because we believe that makes things more maintainable, more approachable, and all of those things. It's that philosophy, essentially.
Okay. So I was reading through the docs, and one of the differences with TypeScript that it lists is that, as you said, TypeScript tries to type the entire JavaScript API, which is crazy. There's lots of stuff that can happen. Just even the way they're able to know that code paths have certain values available and types have happened. Crazy stuff is happening there. But on the homepage, you guys say that you only do a subset of JavaScript. So in practice, what does that mean? What don't I have available to me? What programming constructs do I go to instead of other ones?
There's plenty of stuff you don't have available to you, so to speak. So one, classes is the main thing maybe in Rescript. You can get a development workflow that's very similar to the ergonomics of classes and methods and those things, but you don't have actual classes in the language. You don't have inheritance, those things. It's functional in that sense. We encourage you to write functions that operate on data and that you can chain together and those things. So that's one example. There's plenty of others. The JavaScript API is massive. We don't have generators, for instance, generator functions, although we're interested in getting them. But essentially, when we look at what things to bring into Rescript from JavaScript, we want them to work well with what we already have. So the core kind of features of the language, for instance, variants, records, pattern matching, those things, we want them to should work really well with them. It should also add something, because we view all of the adding something to the language is a huge cost, in that you're giving people another tool that they may or may not use, but it can create confusion around, should I use this for this or that for that, and so on. So we want it to be as simple as possible. So the bar for adding new stuff is high, but we also want to stay close to what the JavaScript developers typically want to use. So one example is asynchronous programming. We could have probably come up with a bunch of other ways of doing this than the native JavaScript way. There's tons of prior art in both our kind of mother language, OCaml, but also in other languages for how to do asynchronous and concurrency and those things. But we opt to build async await into the language just like it works in JavaScript, just because it's familiar. It's something that's virtually everywhere in the JavaScript ecosystem. And it has some kind of it gets some interesting traits in Rescript that makes it more ergonomic, I would say, if I dare, than in JavaScript and TypeScript, so to speak, which are kind of interesting. It's a good example of when bringing something in and making it work well with the existing language yields a good kind of synergy effect, so to speak. So for async await, specifically, it's in Rescript, everything is an expression, which means that if you've ever done a React component and you're 2 layers of divs in and you want to write an if, and you can't, because you can't write expressions in the middle of JSX. You have to write a ternary or some other, make it a function, compute it before, or everyone has felt this. In Rescript, everything is an expression, so you can put an if or whatever you want, a block of code, wherever you want, essentially. Mm-hmm. And what's great about this, doesn't sound that much just from the get-go, but what's great about this is that it allows you to co-locate your logic where it's supposed to be. So if you're forced to break something out to a function when it's only really for this place, you're forced to do an immediately invoked function or a nested ternary of 5 levels or whatever. If you're forced to do those things, you're doing them because of a limitation, in quotes, of the programming language, not because that's what you want to do. And expressions everywhere is a very nice thing that lets you put code where it belongs. And for async await, in Rescript, the big thing is a switch, essentially. It lets you pattern match on anything. So it's like the switch in JavaScript, but on steroids is usually what we say. So you have a switch, and then you can switch on virtually any data structure, and the compiler will make sure that you handle all of the possible cases for this data structure. And you can also switch on an await. So you can switch await, and something happens. And then you can pattern match on that promise throwing or failing, rejecting, and on it succeeding. So you can get this nicely boxed in error handling that's very succinct. It's literally one extra line, and it compiles to the regular try catch, and then define your variable above in the scope and assign it, or use a var if you're that kind of person. And then you have your try catch and find those things. But it lets you integrate this right into the code where it matters, so to speak. So you don't have to do this ceremony of writing a try catch, even though that's not really what you were after, so to speak. So that's a good example of when a feature from JavaScript blends very well into the core features of the language. And that's the kind of things we try and find. So when we bring in new stuff, which there's a high bar, but of course we want people to be as productive as they can be with JavaScript through Rescript. So we want to bring in stuff from JavaScript as well. But there's a high bar. But when we do it, it's important that it works really well with the rest of the language.
Yeah, the switch await thing is really nice, because I think one of the problems I have with async await is so many people just don't do error handling. Yeah, it's just they only code for the happy path, because it's annoying a little bit. And you see a lot of libraries that come out. That there's one that I used for a long time that you essentially wrap whatever you're going to await and await that thing, and then it'll return tuple, essentially a array with 2 items. One could be the success case and one could be the error case, and then that messes up the type inference and a bunch of other stuff. So it's I don't know, it's nice. And I would go further to say there's so many niceties just because it's a functional language. You had mentioned pattern matching earlier. like proper pattern matching, so good.
Yeah.
I use TS pattern a lot in TypeScript
Yeah.
projects. It's unfortunate that's a runtime cost that you have to pay. And then proper like variant enums Rust has. It's like that's missing from TypeScript, JavaScript world. The pipe operator, which we've been talking about in JavaScript for a long time, but like can't collectively agree on like how we want it to work.
Yeah, like pattern matching is probably the thing that when people go into Rescript and then go back out of it, that they miss the most, just because it solves so many problems and quite elegantly as well. And it's, again, you can emulate this well in TypeScript, I would say. Like TS pattern, for instance, is very cool. There's a bunch of other pattern matching libraries, but it's runtime. It's not first class in the language. In Rescript, it compiles to really efficient JavaScript as well. It compiles to what you'd write by hand if you had to optimize it, which is a bunch of ifs, essentially. But you don't want to look at that. You want to look at the nice switch instead. But it's one little thing about switch await and those things. One other really good thing with having a sound type system is that you can do very much with statical analysis or static analysis around your program. So one example is we have a tool called reanalyze in Rescript that can go through your entire program and figure out exactly, for instance, say that you have a variant case or you have a record, it can figure out that this record field is never read. It's constructed, but you never read it, for instance. It can figure out that it's never read nor written to or created. And going back to async await and error handling, it can also actually figure out that here's a promise that could reject where you haven't handled the rejection, the possible rejection. So it can do that type of linting for you. And it's a whole program thing, and it's also very fast. So it's something I use all the time. And one of the things I perhaps miss one of the things I miss the most, I would say, when I do TypeScript stuff, because I still do a lot of TypeScript stuff, and being able to start reanalyze and have it analyze the code base and tell me what things are dead code. So like across the entire program, what things am I not using, and down to the field level. That is, for me, who do a lot of work in big code bases of various kinds, being able to reliably clean up old code is actually one of the biggest wins for me with a sound type system. Just because otherwise, you know how it is, like old experiments, things lie around, new person comes in, they browse the code base, they're supposed to find information about something. AI nowadays, also like the agent browses the code base, tries to figure out information, goes through a bunch of code that's really dead or old or in another convention or whatever that should be removed, essentially, outside of the obvious like gains of compilation speed and bundle size and all those things. So that's something that's a benefit of the soundness, that you can do that with the type system.
Speaking of soundness, you mentioned like there are types on the edge of the system that you have to define, and that's your like barrier of soundness, right? Like things outside of the Rescript code are unsound. And TypeScript has this same problem, right? They have to define type definitions for everything. And like famously, TypeScript has now, at this point in 2025, just a ton of type definitions for everything, just about. Definitely typed has a ton of types in it, but there are like most libraries these days, it seems like they ship their own TypeScript types. So when you think about Rescript's interopt with the rest of the JavaScript ecosystem, or like defining types for outside things, it's like, what is the story around that?
I would say this is definitely one of the points of the language where we have a lot more work to do, or rather in the ecosystem, I would say. In Rescript, interoping with JavaScript or TypeScript, you write bindings, which essentially are ways of describing that if you call this function in JavaScript, you're supposed to expect these parameters, it returns this thing, and so on. It's a description of what the outside world looks like. And then you get access to those functions in Rescript, and the emitted JavaScript is just what you'd expect, like the calls for JavaScript. The big issues that we have around this is that while Rescript and JavaScript has a lot of similarities, there are also a bunch of things that you do in Rescript, in TypeScript and JavaScript that you don't do in Rescript, or can't do in Rescript, so to speak. Overloads is an example. Rescript doesn't have a concept of overloads, which is something I've really come to appreciate, in the sense that it's very clear, like exactly what things can do. But it also means that you can't one-to-one express a TypeScript with code with overloads in Rescript without breaking out each overload to its own kind of function binding. So there are like differences in the type systems that make, because what people come to always is, can't you build a tool that automatically generates Rescript from TypeScript? And back before all of the TypeScript wizardry, this was something that people were exploring, but the results were never really satisfactory because of both the fact that it's quite different type systems, but also that writing the bindings is an art, so to speak. Like you usually when you use a library, you're very seldom using all of it. Most often you're using a small part of it, and you want to use it in your specific way. And there's a bunch of ways to write bindings in Rescript that lets you tailor the API a bit in how it looks. So like you can inject default values for arguments, for instance. So one classical example is the read file sync API of Node, or read file for that matter. Doesn't have to be the sync version, but that takes a file path, and then you can pass the string of the encoding, right? The encodings in most cases is going to be UTF-8. So you can create a binding in Rescript that has a default value of UTF-8, a string, for the options parameter. So you never have to write UTF-8 in Rescript, but the emitted JavaScript always has UTF-8, but it's not wrapped in another function. So it's not a wrapping on top of the Node API. It's built into the binding itself. So like writing bindings is an art, so to speak. But then we have also going the other way, going from using Rescript code from TypeScript. And luckily there we have a bunch of nice stuff in Rescript. We have a tool called gentype, which you just annotate your types and Rescript functions and values. And then a TypeScript file for each Rescript module gets generated with all of the types in TypeScript, but translated from Rescript, so you can easily use them. But this, like the binding space, is of course a big problem. It stems mostly from, I would say, from us being a small community. So definitely type nowadays it has everything and then some. But back in the day when TypeScript was fighting it out with Flow, essentially, it also had a bunch of things, but most were any stubs, right? The same with Flow typed and all those things. So we're at that stage now where when we grow, when we grow a lot, there's going to be quality bindings. But it's also a thing where I think people overestimate how much they use libraries and how much time they would spend writing the bindings for those libraries. But it's a thing where it's hard to say anything else than this is a problem, essentially. AI is going to help some, like teaching the AI to write good bindings helps. We're also experimenting with, so like Rescript can emit TypeScript as an interop layer, so you can call Rescript code type safely from TypeScript. But we're also experimenting with, okay, so can we have Rescript, the compiler, or gentype, the tool? Can we have that emit a file that just checks that the bindings you've written would work with the TypeScript types of that library, so to speak? So if I have this binding for, we'll say React, for instance, for use memo or whatever, is this function signature of the binding I've written, is that compatible with the use memo from the React types package, so to speak? So we're doing a bunch of exploration around how we can improve the situation, because it is a problem. If you're in the blessed path, like you come in and you work with React, for instance, where we have great bindings, and a bunch of other libraries where we have great bindings, then you're pretty much set, like it's going to be fine. But if you need to wander off yourself into writing bindings, it can be daunting.
So code is just the tip of the iceberg when it comes to the JavaScript world. For better or worse, we have lots and lots of tooling. We have linting, testing tools, bundling tools, build tools, all different types of tools. What's the story for Rescript integrating with those? Does it like boil the ocean view of it and do it all for you? Or is it interoperable with the common tools we use today?
Yeah, one of the goals of Rescript is to integrate as cleanly as possible into the JavaScript world. So this means, for instance, you use NPM or PNPM or whatever you want to use, but you use the JavaScript ecosystem for packaging, for instance. You use the same bundlers. What Rescript does is, for each Rescript file, it will emit a JavaScript file that looks as handwritten as we can make it look, essentially. Like it's supposed to look roughly as what you'd write by hand in JavaScript. Our goal is to integrate cleanly into all of those things. Your bundlers, linting, of course, is a thing where it makes more sense to do it in Rescript itself, to lint in Rescript. We also linting is another topic, but we don't have that many linters because we have such a tight type system, we have a couple of like compiler warnings and stuff. So we haven't really seen the need for that. But you could lint and I know people do, you could lint the JavaScript output. People use the React hook lints, for instance. We did a bunch of work we have a version 12 that's coming up here soon. We have done a bunch of work for making sure that the Rescript output can work with the React compiler, for instance, efficiently. All of those things that comes with having a goal of interoperating as cleanly as possible with JavaScript.
Yeah, that I was going to ask that when we got to the React section, if it integrated with like kind of the bleeding edge tooling of the React ecosystem. That's super cool that you can run stuff on the output and like it's good enough output that you can like translate that back to the Rescript code.
Yeah.
Justin,
do you typically, this is a bit of an aside, but do you typically like check in the JavaScript code?
I don't actually, but it's a problem. Like we usually recommend you to check it in. I find it a bit noisy, but I've been working actually quite recently on, okay, so if we don't check in our code, how do we make sure we don't miss accidental behavioral changes? Because imagine, go back to this thing with, we have a sound type system, I make changes, it compiles, I can trust it. So that's good, but there's another layer in Rescript, which is the emitted JavaScript. So what if there are changes in the emitted JavaScript that I wasn't anticipating? Now, like the compiler is very well tested and everything, so it's not, you can trust output, but still, like when you do refactors, when you do bindings, when you do upgrade versions of the compiler or other versions of libraries, and it can be nice to just scroll through the actual like JavaScript changes. Also, like when you do a refactor that's purely on the type level or something like that, you restructure how things work. It's nice to, when it compiles and you also see that there are no changes in the actual JavaScript, then it's going to work, right? It's not going to be any behavioral changes because the generated JavaScript is the only thing that matters to the end user because that's what gets run. I've been exploring building a sort of a diff tool for that. So you could have a CI action that always gives you a HTML diff page you can scroll through for that. It's also interesting to do that type of diffing of the code you've made purely at the type level. So we could have that's for generated JavaScript, you diff the generated JavaScript. For the type level, you could have a diff that just shows how the type signatures or the type output of all files have changed, so to speak, so that you haven't also accidentally made any changes that you weren't anticipating. And for us, a goal is also that all of these things should be easy to plug in an AI that can do, for instance. So an AI could audit your generated JS changes or your type changes or whatever. Like nowadays, it's always in the back of the head that it's supposed to work well with that as well.
Makes a lot of sense. Yeah, so let's switch gears and talk about React a little bit. So Rescript has first-class support for React. And I guess when we talk about React, we also have to talk about JSX, which is like a language feature as much as anything else. So how do you handle React and what does JSX look like inside of Rescript?
JSX, starting that end, JSX is a first-class feature of the language, which means that it's integrated into the actual parser. It's an actual JSX nodes are actual AST nodes in the compiler. And so it's a first-class kind of thing. Everything works well with JSX. Then we have React, of course, which is where we've put, especially historically, have put all of our effort, so to speak. We're very much trying to make one use case work really well, and then we try and move on to the next thing. And React has been, of course, with React's popularity and the roots of the project, React has been huge. So I would say we have very good React support. It's something we care a lot about. It's a package maintained officially by us, the core team. But we've recently also started working a lot on trying to make other frameworks that work differently work well as well inside of Rescript. So we've been eyeing Solid.js, for instance, Preact, but that's cheating because it's still React. But also other use cases, because JSX is cool. And especially when you have all of these nice features around pattern matching and those things, you can do a lot of cool things. So for instance, I've built a framework that's based on Bun, that's purely server-side, but that you write components just like you'd write your regular app. You write JSX components, you render them, you have context, you just don't have the client-side stuff. You don't have use states and everything. And what that JSX looks and works exactly like the JSX you'd write in Rescript for React, but in the end, it gets compiled and down to calls to a framework called Hyperons, which is a small framework that just produces HTML from JSX. So given that it's first class and you nowadays can switch out React to your own thing or another library, it opens up some pretty interesting use cases, I would say. But yeah, historically, React has been the main focus. And there are a few things in React lends itself really well to a language like Rescript because of a couple of things. First, of course, the thing I talked about before, expressions everywhere, switches and stuff, but also something as simple as prop drilling. That's not really an issue in Rescript because you have the inference. So you never have to, unless you want to, you never have to annotate a prop. You can always let the inference deal with all the props. And that's a huge, for me at least, been historically a huge source of friction otherwise. That makes you skip doing a few things because it's annoying to have to type it all the way through, essentially. I would say that's one of the big kind of benefits of a language like Rescript and JSX and React together.
It's interesting how when you make JSX a language feature and kind of factor it out of React, like the way I think about React and what it is and what it's doing in my application, like almost completely changes. And it's really cool that you can use that for other things. Just like you basically created your own little framework with not too many bells and whistles.
Yeah, and JSX can be molded to. Off the web is still like XML based in most ways. You can use it to, just like other people do in the TypeScript world, of course, but you can use it to emit XML or CSV or whatever. It's just function calls at the end of the day, right? So it's just a nice format for those function calls and structuring them in a nice way. So of course, like I said before, I absolutely hated JSX when I saw it first, but I really like it now and I have been liking it since a couple of weeks after hating it.
Yeah, I've found that trend in my life as well, especially like with music. I'll like hear something and have almost a visceral reaction to it, like that's bad, and then it gets stuck in my head, and then lo and behold, that's like one of my favorite artists a year later.
Yeah. Then the shame, right? Like you have to admit no, I didn't say I didn't like this. No, you must have misheard.
So React for around 18 versions was the same. React 19, I feel it threw a lot of that out and became very different. You guys list that you support like the normal hooks, but React has a whole bunch of other hooks now. It has concurrent mode. It has a bunch of bells and whistles that it didn't in like most of its history. Does Rescript support those things or plan to support those things?
Yeah, like the React compiler is one example, of course, where we've actually had to do a lot of work to mold our output to work with the compiler. One example is that we now have a JSX preserve mode, which means that the JSX you write in Rescript, you can have Rescript emit that as JavaScript as well. So there's actual JSX in your JavaScript that gets emitted, and that's needed for the React compiler. There's no that I'm aware of, nothing in the recent React versions that, from a language standpoint, cannot be supported. Things we traditionally have issues with is things like file-based routing, where in Rescript, everything is a globally unique module. So all files are in the same shared global scope. In addition to binding, this is also one of the things that people think they will hate the most when they come to Rescript. And some people, like, gotta be fair, some people really do hate it, but most people don't, like when they come into actually using it. But that also means that we can't have 100 different utils.res files, which I would say is good, but we also can't have 100 different brackets ID brackets.res for file system routing. So you have to, when you want to use that, you have to write your route files as JavaScript and then import Rescript into that, which also works fine, but it's more work, of course, and a bit of friction. But outside of that, I don't think there's nothing I'm aware of in React that we couldn't support or don't support.
As you think about the Rescript ecosystem, you mentioned earlier that there's like a blessed path. There's some libraries that have really good support, or I'm sure there's some libraries that were just written for Rescript itself.
Yep.
What does that ecosystem look like? What are some of the like very well vetted, very well engineered like bindings or libraries that are like pretty common in the Rescript ecosystem?
Yeah. Of course, React is one example. We have a very cool schema library in the ecosystem. If you're a Valibot, which is by a person in the ecosystem who's very well versed in the schema stuff, and it's really fast, really innovative, and very good. Overall, we've traditionally had a lot of GraphQL stuff that works really well, just because GraphQL and Rescript. Nowadays, there's a bunch of other solutions to end-to-end type safety, of course. But traditionally, GraphQL, when it came, gave a lot of possibility of end-to-end type safety, and that just lends itself quite well to Rescript. GraphQL is funny because I've been working with it for ages now, and it's still, if you squint a little, GraphQL and Rescript is really similar in the concepts they have. GraphQL is like a subset, I would say, or a limited set of what Rescript has, essentially. But like unions, enums, those things, it all pretty much looks the same in GraphQL as it does in Rescript, for instance. So it maps really well back and forth. We have a bunch of other things like the node stuff, of course, bun and other things as well. And then there's a bunch of innovative, like own Rescript stuff around forms and other things, so to speak. Yes, there's a couple of different things. And then there's lots of things in the works too.
You're working on version 12. Is it in beta now?
Yeah, it's in beta. It's now, I dare say it's really close, but we've been doing a lot of things for version 12. So it's taken a lot of time to get this working really well.
What are the big features that are coming out in version 12?
So version 12 has, the big thing for us who's been around for a while in Rescript is that version 12 does all of the like remaining big cleanups from our history, so to speak, in molding Rescript into this JavaScript focused language that we want it to be. There's a bunch of things around that. We've replaced the build system completely, which yields some massive speed ups in some cases. I have a couple of projects, for instance, where it's 60% faster to compile from a clean slate and so on. So that's the thing. There's a bunch of other things in the language itself, much better support for dictionaries, lots of more like powerful type things in how you can structure your types, how you can move between types, how you can share things between types and those things. We have a couple of experimental features that I'm really excited about as well. Yeah, so it's packed with things, essentially. And we're starting to, some of the things in it are nice because they give us a receipt that we've been able to make things work nicely together. Just like I talked before, like we want things to work well together. And that's usually quite a big challenge, right? To make things really work well. So one example is we've now gotten to a stage where you can model JSON as a variant in Rescript, so as a union, so to speak. And with pattern matching and all of those features, that means that you can write JSON decoders and encoders fully just in the language itself, right? So you can have a JSON structure that you get from an API, and then you can pattern match your way on that to what you expect it to be. So for instance, this JSON, I expect this to be an object. It's supposed to have a user prop. That's supposed to be another object. It's supposed to have a name prop that's a string. It's supposed to have an age prop that's an float or int or whatever, and so on. So that's a testament to all of those things working really well together, right? So like the features of the language come together in a nice way. And V12 has a lot of things around that, essentially. And then a bunch of optimizations. And yeah, again, like it's packed. So we're really looking forward to getting this out. And for us, it's now that we've finally done a bunch of, like we've cleaned up a lot of things. We've replaced the entire standard library, for instance, to something much more closer to JavaScript than what we had before. And we worked hard on making sure that transition is hopefully going to be quite easy. So we built an entire like migration framework where you can automatically migrate from the old standard library to the new standard library, even if the signatures of the functions are wildly different in the old standard library to the new one, and so on. So we're hoping that from version 12 and on, we're going to be able to focus more on just sharpening the language rather than making sure that everything fits well together like we've been doing now.
So we just talked about V12 a little bit. You got a lot of exciting things coming, like jam-packed release for sure. Where do you want to see Rescript go in the next 5 years? What's your vision for the ecosystem?
I would say continue bringing things in from JavaScript and molding it to like the useful things, molding it to work in the Rescript ecosystem, so to speak. But I'm also quite interested in and excited about general AI stuff, like how a language like Rescript is suited for agentic coding, for instance. And that's something where we've actually spent a lot of time now with V12, for example. Something as mundane as error messages is hugely important for an agent to be able to recover, right? So you want to get to a place where you can put an AI agent on your code base and just have it bang its head on the computer until it compiles, right? And in order for it to be able to do that, you have to have error messages that hint on on what's wrong in a good way and how to fix it, especially for a language like Rescript that's small, where you don't have the benefit of there being massive amounts of training data for it. But Rescript lends itself really well to AI coding just because the feedback loop is so fast. It's really simple. If it compiles, it works, all those things. And also that the type system is simple in a way that makes it possible for us to, I would say in if not all, then most situations, give you an actual good error message. Like we don't now, but we could. So and we spend a lot of energy in trying to make this really work. Because most often when something doesn't compile, you're doing something wrong, and we can figure out what you were intending to do. And in the best case scenario, we can just say that, oh, this is supposed to be this thing instead. But in the more common case, there's maybe 3 different routes you could take from here. And we could present that to the user or to an agent and let them decide on which way to go, essentially. So there's a bunch of things I'm working on right now that I'm really excited about that specific thing, because of course, like AI is going to be big in the future as well. But we also like just finding all of these like patterns that make you able to write good apps. So one thing that's very popular now is errors as values and exhaustive error checking for all the code, like Effect, for instance, has. And that's a thing that's actually first class in the language. And you can do it all also very driven by inference. We have the result type. We have options and result types built into the language of Rescript. And there's a concept, I'm not going to bore you with the details, but there's a concept called polymorphic variants in Rescript, which are essentially structural unions of things. So in Rescript, you can write functions that return results. You can mix them freely between async and not async because you have async await. And all of these functions, as you call them throughout your application, the type system can track all of the possible errors that can be produced by those result types and then force you to handle these whenever you call the function. Like a great pattern that's thankfully getting popular now as well. But the cool part about it is that it's all native and built into the language itself. And it's all inferred. So you don't have to write any annotations. You don't have to pre-declare. You can go into function 2 of the 10 functions you call in your decode function and have that produce another error. And then all of the call size in your code base that interacts with that is going to force you to handle that automatically, so to speak. So there's a bunch of those things as well that's interesting to see how we can get closer to and make easier.
Yeah, errors as values seems like a super useful feature. We've talked about it a lot on this podcast. Well, thanks for coming on. Justin has to give up his room. Well, thanks for coming on. We covered a whole lot of ground here about Rescript. It's a very interesting language, and I might give it a try. I particularly, we didn't talk about it, but your Rescript relay package looks like phenomenal. There's barely any README there. The API is so nice. So thanks for coming on and telling us all about Rescript.
Thank you very much for having me. Very enjoyable. Thank you.